Hey everybody, welcome to section 4.3 in our calculus class, and I'm going to jump right in. We did part one and part two. We learned about how to take the second derivative test, for three-dimensional graphs for functions of two variables. And now this third part, we're going to go through some, few examples and get some. And every time we go through an example, you get more insight. It's a wonderful thing. So I'm gonna jump right in, and we're gonna start right now. Let me just switch cameras. Gotta switch cameras. Now when I switch cameras, oops, that's my arm. Um, when I switch cameras, I have to get rid of the virtual background. It messes things up. So I gotta just get rid of the background this way you can see the paper. Okay, perfect. Now you can see the paper, and we're ready to rock and roll. Okay, so let's do it. Let's do an example right now. Here we have, so again, as I said, we're in 4.3, and we'll do an example, and that is x cubed plus y cubed. Uh, you know, f of x comma y equals x cubed plus y cubed plus 3x squared minus 3y squared minus 8. And we want to find the max, if there's any, mins, if any, and saddle points, if any. So, so let's do it. Let's do it. So the first thing I want to do is I want to find fx. So fx, that's equal to 3. Well, let's look at here. The derivative of x cubed is 3x squared. That's y, as far as x is concerned, y is a constant. So that just goes on vacation. This becomes plus 6x, and that disappears, that disappears. So it's very simple. Fy, being the partial derivative with respect to y, well, that disappears. That's 3y squared. That disappears. That's minus 6x. And the 8 is going to disappear. So far, everything's good. So far, we're in good shape because like everything's disappearing. All right. So let's go on to the next thing. The next thing I need to do is, now I want to just put a little red mark here. We're gonna the FX is going to be important for other reasons besides, well, this is going to be important for a bunch of reasons. Uh, but let's figure out the second derivatives now. Let's figure out the second derivatives. So the second derivatives are, drum roll please, fxx. Now what I want to do is I'm going to put there are four of these. As you remember, there are four cases. So the ones where x is first, I'm going to put them over here. fxx and fxy. And the ones where y is derived first, put that over here. Fyy and fyx. Okay, well, fxx, that's just going to be the derivative of 3x squared, which is 6x, plus 6. fx fxy means I'm going to take the derivative of fx with respect to y, but there's no y in here. So fxy is just going to be 0. Now on this side, well, fyx, well, let's do I just realized I made I guess I'm going to call it a typo. I wrote minus 3x. That should be, but I got it from here. So that should be minus 3y. Minus 3y is. All right, very good. Fyx, well, the derivative with respect to x of this guy right here is just 0 because there's no x terms in there. So it's all constants. fyy is I want to take the derivative with respect to y. So the derivative here is going to be 6y. That's going to be minus 6. Yeah. Okay. So let's, what I want to do now is I want to find all the critical points. And if you remember, the critical points are all the points where fx and fy are either equal to 0 or are undefined. Now, these guys are never undefined. These are basically just fx, and fy. They're just basically polynomials. So they're never undefined. So I want to find when they're equal to 0. And I need both of them to be equal to 0. So what I need is this guy right here, 3x squared plus 6x. Let me change color pen. 3x squared. I need for 3x squared plus 6x equals 0. And I also need 3y squared minus 6y. I need that to equal 0. Well, we're going to factor each one. So this, I'm going to pull out a 3x. So I have 3x times x plus 2 equals 0. And that tells me either x equals 0 or x equals negative 2. And that's from basic algebra, which you've done a million times. Here I'm going to pull out 3y, factor out 3y, and I get y minus 2. And that either tells me that either y equals 0 or y equals 2. So I have 4 possibilities. Let me put all 4 of them. I'm going to put them over here. So the 4 possibilities are either x is 0, y is 0, x is 0, y is 2, x is negative 2. You know, in other words, there are 2 possibilities for x, 2 possibilities for y. I have to account for every combination, and there are 4 combinations. So my first critical point is going to be, let's do this methodically. 0, 0. Meaning x is 0, y is 0. My second critical point is going to be x 0 and y is 2. My third critical point is going to be x is negative 2 and y is 0. And my fourth critical point is x is negative 2 and y is positive 2. So now between these four options, these possibilities, I basically have every combination of fx and fy being equal to 0. It's all cool. It's all good. Now you have to test these critical points because as you remember, just like we had when we did functions of one variable, just because something in order to be a max or a min or even a saddle point, it has to be at a critical point. But not every critical point is a max or a min or a saddle point or whatever. And even if it is, which one is it? Is it a max? Is it a min? So we have to like test out each of these critical points, and we're going to use the test that we just learned in the previous video. Which means I need D. And D, not defense. D is, if you recall, D is going to be fxx fyy minus fxy fyx. And that's going to be fxx, which is 6x plus 6, times fyy, which is 6y minus 6, minus fyx times fxy, which is just 0. So basically, what I need to know, if you really want, if you want to be picky, I can write 0 squared if you want. It's really that 0 times that 0. Wow, it really matters. Anyway, we want to test these now to see how they do. What happens? Excuse me. What happens when I plug these critical points into the x's and y's over here? So there are 4 critical points. We're gonna have to make 4 evaluations. So I'm going to call them D1, D2, D3, and so forth. So D1, I'm going to take 0.1. So that's going to be 6 times 0 plus 6 times 6 times 0 minus 6. That just winds up being positive 6 times negative 6, which is negative 36. Now, negative 36, even I know, is less than 0. Since it's less than 0, that means you have a saddle point. So that's our first critical point. Now, for our second critical point, which is 0, 2, so it's going to be 6 times 0 plus 6 times 6 times 2 minus 6. And that's going to wind up being, well, positive 6 times, it's actually, is actually 12 minus 6. So it's positive 6 times positive 6, which is positive 36, which, and since it's positive, since D is positive, I know it's a max or min, but I got to figure out which one it is. And I do that with my fxx, this guy right here. Let me underline that. We're gonna have to refer to that. So I'm going to now. If you notice, fxx in our example only has x's and no y's. So therefore, all I really have to plug in is the 0. So fxx equals 0 plus 6, which of course is equal to 6, which is greater than 0. And since it's positive, it is a min. By the way, it's interesting because in functions of one variable, we did on the plane, if the second derivative is positive, that means the function is concave up. Well, if it's concave up, that means the critical point is a 0, is a minimum. It's on the bottom of that, So the correlations, are very, as I mentioned in the previous video, very pronounced, very staggering, very, very fascinating, as a matter of fact. Anyway, let's look at the third critical point, negative 2, 0. So that's going to be 6 times negative 2 plus 6 times 6 times 0 minus 6. And that gives us, let's see, that's going to be negative 6 times negative 6, which is equal to positive 36. So again, I have to test fxx. I can't just copy what I have up here. I have to put in the new values of this new point. So I have to put in x is negative 2. So it's going to be, let's see, 6. So I'm going to 6 times negative 2, which is negative 12 plus 6. And that's negative 6, which is negative, of course. So therefore, it is a max. And finally, D4, fourth point, negative 2, 2. So I'm going to plug in, well, when I plug in, where are we here? To D, I get negative 12 plus 6. Here I get, and over here, I get positive 12 minus 6. When I plug in x is negative 2 and y is positive 2. I have to look at my D. And that winds up being negative 6 times positive 6, which is equal to negative 36, which is less than 0, of course, negative. And that's another saddle point. So there you go. So let me just here in one little table. So this is a saddle point. That's a min. That's a max. That's another saddle point. And this is what happens with my 4 critical points. This is what happens with my 4 critical points. Very fascinating indeed. I'm going to put this in a big box. Nice little box. That really kind of summarizes the whole thing right there. So I roll one nice little table. Beautiful. Okay, let's go do another. Let's do one more. See how much fun this was. Let's do another one. Okay, here we go. So we're gonna do an example. Uh, Here's a nice function. We're gonna do z. So z is equal to 9x cubed plus y cubed over 3 minus 4xy. Here's our function. And let's see what we could do with this guy. So, so, uh, so I'm going to do pretty much, same procedure. I'm not saying it's going to work out exactly the same, but I'm going to do the same procedure. I'm going to start with my zx and my zy. So zx, well, let's see, that's going to be 27x squared. That disappears, and that becomes just minus 4y because the 4y is a constant. It's not a you don't. There's no product rule here. It's just a constant. So that's going to be minus 4y. And zy, well, that's going to disappear because that's just a constant. That's going to be 3y squared over 3, which is just y squared. And that's going to become minus 4x. That's like I'm just bringing down the constant. Now, to find the critical points, oh, I'm sorry, before I do the critical points, let's get our zxx, zyy, all that other stuff. Because I won't be able to do anything with the critical points if I don't have these other things. So I'm going to do z. So first, I want to just underline this in red. Just let's see. And we have zxx and zxy and zyy and zyx. Okay, so this becomes, let's see, 2 times 27 is 54. 54x. That disappears because y is just a constant. And zxy, well, this is going to disappear, and that's just become negative 4. Now, zyy, that's going to be 2y, and that's going to disappear because it's just a constant. Zyx is going to be, again, just negative 4. So again, xy, yx are the same. Uh, Now, this is this is a little interesting here because we have to find the x and y points that make both zx and zy equal to 0. Making them undefined, that ain't going to happen because these are polynomials. They're never undefined. But we had making them equal to 0. But then making them equal to 0 is interesting. I really wound up with a system of simultaneous equations because I need 27x squared minus 4y to equal 0. And I also need y squared minus 4x to equal 0. So I need both these things at the same time. So what what I'm going to do is I'm going to use the second equation and I'm going to solve for x. It's not the only way to do the problem. That's how I'm going to be doing it. I'm going to take the second equation and solve for x. So I get from the second equation, I get x is equal to, let's see, I bring the other side, y squared over 4. Because I brought the 4x to the other side, divided everything by 4, and y squared over 4. Now I'm going to take this, this x equals y squared over 4, and I'm going to plug it in to the second equation, I'm sorry, to the top equation. So my top equation now becomes 27 times y squared over 4 squared minus 4y. and that equals 0. Now it's one equation with one variable. I can solve it. So the first thing first thing I want to do is get rid of all these parentheses. I'll make it a little bit easier to see what's going on. So we have 27 over 16 times y to the fourth minus 4y equals 0. So I'm going to factor out a y. 27 over 16 y cubed minus 4. And I set each guy equal to 0. So this just gives me y equals 0. This just tells me 27 over 16 y cubed minus 4 equals 0, which means 27 over 16 y cubed equals 4. And then I multiply by the reciprocal. I get y cubed equals 64 over 27, which, by the way, is a perfect cube. So y is going to be equal to 4 over 3. So I have two possibilities now, y equals 0 or y equals 4 over 3. And once we have those possibilities, now I got to figure out, well, what's x? What's x going to be? If y is 0, what's x going to be? If y is 4/3, what's x going to be? By the way, we only have two possibilities, and now we're going to go. Now, finding out x is going to be very simple because I have right here x in terms of y. So if y is 0, so x is going to be 0 squared over 4, x equals 0. So that gives me 0 comma 0 as a critical point. I'm going to put up here in my little box. If y equals 4/3, then I have that x equals 4/3 squared over 4, which if I simplify this, just becomes 4/9. Because one of the 4's cancels with that bottom 4, and then I have another 4 left, and 4/9. And now, which would correspond to the point 4/9, comma 4/3. So that will correspond to this point 4/9, comma 4/3. So I have my x and my y. So that's my critical points here. Okay. So my critical points, which I need to test, are 0, comma, where are we? 0, comma 0, and 2, 4/9, comma 4/3. Now to test them, I need to find D. The D is going to be zxx times zyy, which is, let's see, 54 times 2 is 108. Minus zxy times zyx, which is minus -4 times -4. So it's minus -4 times -4. So it's three minuses. So it becomes negative 16. That's my D. I'm gonna put D in a box. Now all I need to find, there's only two critical points, so I just need D1 and D2. So D1 is just going to be 108 times 0 times 0 minus 16, which is just 0 minus 16, which is just negative 16. And of course, negative 16 is negative, so it's a saddle point. And now D2, that's going to be 108 times 4/9 times 4/3 minus 16. And this we have to see. I know that this is all positive here. I got to see if it's bigger or smaller than 16. Well, the denominator is 27, and 27 actually goes into 108 4 times. So this is going to be equal to 4 times 4 times 4 minus 16. And that's 64 minus 16, which is 48, which is positive. So because it's positive, I have to look at fxx. In other words, since it's positive, I know it's going to be either max or min, but I got to figure out, I got to find which one. So I'm going to my zxx, which I just want to say is right here. And 54x. So this is going to be 54 times x, which is 4/9. And the truth is, I don't even care what this comes out to be, because I see it's a positive times a positive, therefore it's positive, and that's all I really need to know. Well, let's just do this anyway. This is 9, that becomes 6, that's 24, which obviously is positive. And because it is positive, because the fxx is positive, we have a min on our hands. So let me just fill in a little table here. So this is a saddle point SP, and this is a min. Now we have all the answers that we could ever want in one very convenient place. Okay, everybody, it's been loads of fun. I have enjoyed this thoroughly, and as I've enjoyed teaching your class. So let me go back. Okay. Oh no, I got rid of my background. Sorry about that. So it's been loads of fun. That concludes this video, and carpe diem, and we'll see you guys next. There's always the next time.